Okay, so now we're gonna start moving into confidence interval. Now, confidence interval. So how I'm gonna give you a percentage. How confident are you? 99% sure, 95% sure, 90% sure that a number is gonna be in between two values, right? Interval is basically in between two values. So now a formula. There's a formula we're going to be using. The formula for my interval is going to be the average, which we called X bar. Sometimes we call it mu, but this is just the average of the sample plus or minus. If I use the plus, it's going to give me a value. If I use the minus, it's going to give me another value. I said my interval is two values, right? So I do expect two values. So plus or minus two values. And then let me use this, my C-score or my alpha divided by 2. That kind of looks familiar what we were doing yet last time. And this thing, I'm going to multiply this by the standard deviation divided by the square root of n. N is how many are in our sample, okay? So let's take a look. This is the formula I'm going to be using. Now, random sample of n measurements was selected from a population with the unknown mean and the standard deviation of 35 for each of the situations. Calculate a 99% confidence interval for mu for each of these situations. N equals 50 and X bar equals 36. Round to 2 decimal places as needed. Okay, so first of all, I need a 99% confidence interval. So what I'm going to do, I'm going to go 0.99. Okay, so I'm gonna do this. I'm gonna go 0.99 divided by 2, and that gives me 0.495. I want a C-score that gives me the probability of 0.495. So do find the C-score. Okay, so using our table, 0.495. Where is that? I'm gonna say it's in between these two values. Because remember, I'm looking for 0.4950. Okay, I know this value, 0.4949, gives me my C-score as 2.57. And I know 0.4951 gives me the C-score of 2.58. So matter of fact, let me add an extra zero at the end. Now, what is the number? What is the C-score right in between them? Because that's the one that I need. I need the C-score that's right in between them. So I'm going to say the C-score that I'm looking for is 2.575. I'm going to use it as 3 decimal places. Okay, now let's take a look. My answer is 2 decimal places, but for right now, my C-score is 3 decimal places. So let me just say it here that my C-score, if you want to, let me write it here. The C-score that I'm looking for, that I'm going to be using is 2.575. And this is the C-score of my alpha divided by 2. Okay, so what do I have now? Let's see what information do I have. Do I have my X bar? Going back to a formula, I see that my X bar is 36. So I have 36 plus or minus my C-score, 2.575. And this, I'm going to multiply this. Do I know my standard deviation? Yep, I know my standard deviation is 35. Divide this by the square root of n. N is how many samples? 50. Okay, it's all numerical. Let me type it in on a calculator. I'm going to go, let me do the minus first to get the small value. 36 minus 2.575 times 35 divided by the square root of 50. According to my calculator, I get 23.2544, and there's more numbers. Let me just leave it at that. 23.2544. Now, my instruction says round to 2 decimal places as needed. Okay, so let me round this as 23.25 as my small value. And I got the small value using the minus. From my formula, I use the minus. Okay, now use the plus to find the big value. So I'm going to go 36 plus 2.575 times 35 divided by the square root of 50. According to my calculator, let me see up here, I get 48.745599. Okay, but remember how my answer, I have to run it to 2 decimal places. So I'm going to call this 48.75. My third decimal number was big enough, so push my 4 up. So my answer is 23.25 and 48.75. What does that mean? Okay, if I had a sample of 50 and my average is 36, my standard deviation is 35, I am 99% sure, 99% sure that any number that I pick will be in between these two values, in between 23.25 and 48.75. Again, if there were 50 numbers, 50 samples, right? There's 50 numbers. The average is 36, the standard deviation is 35. I am 99% sure that a number that I pick will be in between these two values, any random number. That's what the confidence interval means. Now, let's do the next example. My n is equal to 100. My average is 5.83. Because I'm still doing 99%, I'm going to say my C-score is going to be 2.575, right? That's my C-score of 99%. Okay, so how am I going to do this? Okay, let's see. Remember your formula from the beginning. X bar plus or minus the C-scored times sigma divided by the square root of n. So in this case, I'm going to go 5.83 plus or minus 2.575. And then here in parentheses, I'm going to have 35 divided by the square root of 100. Follow me? Okay. My interval. Let me find my small value first. So I'm going to go 5.83 minus 2.575 times 35 divided by the square root of 100. I'm going to round my answer to 2 decimal places, all right? I'm going to round my answer to 2 decimal places. Remember, I used the minus, so it gives me negative 3.18. Good, that's not bad. Negatives are numbers, so it's fine to have a negative. Now let me use the plus for my big number. 5.83 plus 2.575 times 35 divided by the square root of 100. My answer, I'm going to round it to 2 decimal places. I get 14.84. So if I had 100 numbers, the average is 5.83. My standard deviation is 35. I am 99% sure that a value that I pick is going to be in between negative 3.18 and 14.84. Let's change things a little. formula is still going to be the same. You have the formula on your notes on the top. So when I say according to the formula, it is the formula that we have on the top. Now we're going to change this. A random sample of n measure was selected from a population with an unknown mean, mu, and standard deviation is 20. Okay, so my standard deviation now is 20 for each of the situations. Now calculate a 95% confidence interval for mu for each of these situations. So now my confidence interval is 95%. So my C-score is going to be different. Okay, so let's see. 0 0.95, 0 0.95 divided by 2. So I'm looking at this. 0 0.95 divided by 2 gives me 0.475. Okay, let me use my C-score table. Let me find my C value, my C-score. That gives me 0.475. Why did I divide 0.95 or 95%? Why did I divide it by 2? Because my table only gives me half of the graph. So I'm looking for 0.475. Okay. So let's get here. Let me erase this from our previous work. So I'm looking for 0.475. It's right here. Good. That one gave us, I see it. So what's my C-score on that one? Let me zoom out. What's my C-score on that? 1.96. Okay, 1.96. Let's do that. Let's use that. I found my C-score. My C-score I'm going to be using is 1.96. I have my N. As a matter of fact, let me write it down here. The C-score that I'm going to be using is 1.96. Okay, so I think I'm ready for my formula. The formula I'm using is the one on top of our notes, okay? So to find my interval, so I'm going to go, for this case, I'm going to go 21 plus or minus 1.96 times, then I'm going to have 20 divided by the square root of 75. Remember, my 20 is my standard deviation, and my 75, that's my n. But remember, doing square root of 75. Okay, so let me use the minus first. I'm going to use a calculator. So 21 minus 1.96 times 20 divided by the square root of 75. Make sure you know how to type on a calculator. Type in my numbers to make sure you get the same things that I get. I'm going to round my answer to 2 decimal places because it says round to 2 decimal places as needed. So my answer, I'm going to round it to 2 decimal places. In my case, I'm going to get 16.47. My small value is 16.47. Now my big value, I'm going to use the plus now. 21 plus 1.96 times 20 divided by the square root of 75. My case, I'm going to round my answer to 2 decimal places. I get 25.53. Make sure you don't forget to round. I had a 6 that was big enough to push the 2 into a 3. Okay. Now let's take a look at this other one. We're still dealing with a 95%. So I'm going to say my C-score of a 95% is still 1.96. So in this case, I'm ready to use my formula. According to my formula, in this case, I'm going to go 16 plus or minus 1.96, and then I'm going to go 20 divided by the square root of 120. And my interval is going to be in between 12.42 and 19.58. Okay. Now here, random sample of 93 observations. So now we have that my n is 93. Produce a mean of 25.7. So 25.7. You guys might be wondering, why do sometimes the mean, we use it like as a mu, that U-looking shape, and then sometimes we use it as an X with a little line. Okay, because sometimes we use the mu letter, right? Why do sometimes we use mu, and why sometimes we use the X bar? Good, that's a good question. It's an interesting question. Now the mu, the U-looking shape, that is when it's the mean of the population. So it's the mean of everything. The X barred, that's when it's the mean of our sample. So that kind of tells us, is it the mean of our sample? Is it the mean of the population? Now, our standard deviation, I'm going to use an S now. And I'm going to say S is going to be equal to 2.5. I remember standard deviation, we used to use this little shape, sigma. It's a Greek letter called sigma. And now it's going to be S. Well, the same idea for mu and X cross. We use the sigma when it's the standard deviation of the population. And now we're going to use S as the standard deviation of the sample. Now I want you to find a 95%, a 90%, and a 99% confidence interval for mu. So the confidence interval for the population, even though the numbers that I gave you were from a sample. Now, one thing, I see this thing right here. Those are the numbers I'm going to be using. Those are my C-scores I'm going to be using. For 90%, if I have to do 90%, my C-score is going to be 1.645. For a 95% interval, my C-score is going to be 1.96. For a 99% interval, my C-score is going to be 2.575. Now, let's remember the formula from the top of our page. I need to do a 95% interval just for me to remember my C-score of a 95% interval is going to be 1.96. Where do you get that, Mr. Leonzo? From right here, from right here. 95% is 1.96. So that means that for 90%, let me move on here. My C-score for 90% is going to be 1.645. And my C-score for 99%, I'm going to use 2.575. Okay, so I'm going to use those C-scores for the percentages that I have. I have my N value, I have my average, and I have my standard deviation. Right, I have an S instead of a sigma. That's fine. That's fine. It's not a big deal. So for my 95% interval, the way I'm going to write this will be 25.7 plus or minus 1.96 times 2.5 divided by the square root of 93. And my confidence interval, if I use the minus, is going to give me 25.19. If I use the plus, it gives me 26.21. So I'm 95% sure that a random number will be in between 25.19 and 26.21. Now let's do the 90% interval. I'm gonna go 25.7 plus or minus 1.645 times 2.5 divided by the square root of 93. My interval in this case is going to be 25.27 and 26.13. You guys might be like, well, with the 95% interval, with a 95% confidence, my interval was bigger than with a 90% confidence. The higher the percentage, the bigger the interval it is. Well, yes. Remember how at the very beginning I said how confident, for last week, last assignment, I said how confident are you that in your next test you're gonna get between 0 and 100%. Pretty sure you guys will say, well, 100% sure. Well, how confident are you? And then I'll make a smaller interval. How confident are you that you get more than 85%? Pretty sure my confidence interval, if I ask you guys, the confidence interval will be smaller, right? Yeah. Okay. Now let's take a look at the last one, 99% confidence interval. I'm gonna go 25.7 plus or minus 2.575 times 2.5 divided by the square root of 93. And in this case, my confidence interval is going to be 25.03 and 26.37. Okay, let me zoom out. That's what we did today.